Okay, how'd you do with these examples? Good? All right, now, if you've got like one or two and you're like, I just need to fast forward to number, then fast forward. But in the meantime, I'm going to look at number one. And they want to know, without a calculator, what the natural log of E is. Now, I am just going to kind of take the long approach just to make certain everybody is good with it. And I'll use X because some of you are like, I didn't like using M in your lecture video. Fine, no problem. But here's something I'm going to notice. I can rewrite ln as log base E, right? Of E, and this equals X, doesn't it? Okay. Again, I'm taking the long route because I want you to see what happens. I'm going to get rid of log base E by taking exponential base E on both sides. That will cancel log base E and exponential base E and leave me E equals E to the power of X, right? What's the power on this E? A 1. So what does X equal? 1. So here's basically what you're saying. What you're saying is ln of E is equal to 1. What you're saying is log base E of exponential base E to the power of 1, the log base E and the exponential base E cancels out, and it leaves me just the power, in this case, is a 1. With me? When you have a log base whatever, and you have an exponential with the exact same base, they're inverses of each other. They're going to cancel out, and they're basically going to leave you just the power. So in this case, for problem 1, it's going to be X equals 1. So knowing that, what do you think the answer for number 2 is? So you're going to say the answer here is 71. Okay, I'm going to take it the long way. I'm going to say log base 3 of 3 to the power of 71 equals X. I'm going to cancel the log away by taking an exponential base 3 on both sides so I could cancel the log base 3. You're like, why do you do that? I don't like logs without using the calculator. I can deal with the exponential better without a calculator than I can deal with a log without a calculator. It's easier to handle the exponentials without a calculator. Logs, yeah, you kind of need a calculator. Okay, so that leaves me 3 to the power of 71 on the left, and on the right, 3 to the power of X. X equals 71. The long way proved what we just established here. With me? Okay, so number 3, got an idea of your answer? You're right, -1. Do you want me to show the long way? Some of you are saying, no, I get it. Okay, so if you get it, what's the answer to number 4? Good, -4. Do you want to see the long way? No? Okay, got it. How about 5? Some of you have an idea and some of you don't. Okay, so hold on to your idea. I'm going to go the long way. I don't want X. At least let me use a Y, okay? Now, in this particular case, I am going to get rid of this base E. And I'm going to take the ln on both sides. You're like, why are you getting rid of base E? Because I don't like an ln in a power. Just watch. Those cancel. It leaves me ln of 8 equals ln of y. Y equals 8. It doesn't have a choice. So in this particular case, e to the power of ln of 8. Remember what we mentioned. Exponential functions and logarithmic functions are inverses of each other as long as they have the same base. Isn't ln just log base e? Exponential base e, log base e, they drop out, they leave me just the power. Well, in this case, 8. And this is the long way that proves it. Just like I did numbers 1 and 2 the long way, and when it had a log base 3 of an exponential with the same base, it left me just the power. Same thing here. This is the exact same problem as 1 through 4. The only difference is they switched the exponential and the log. But they still cancel because they have the same base, and it left me, in this case, just 8. Good? Okay. I have some additional problems coming your way if you would like to try some different types of log problems that you have to simplify without a calculator. They are a little more involved, so you might want to try them. Catch you guys on the flip side.